Now, welcome to this video. In this video, we are going to discuss laboratory units and field units. Okay. In soil chemistry, we have some quantities or units that are dealt with, okay, or usually used. So, quantities of different substances are measured in different units, okay, and their interpretations are always different. So, we have mass, it's a unit. Okay. Uh, we have so for instance mass as the standard in SI unit to be kilograms. Mass is actually a quantity, usually unit to be kilograms. Um, Volume, those are the unit to be centimeter cube, milliliters, liters, a lot of units. So in this case, you look at two different types of units that are dealt with in soil chemistry or soil science. So what are laboratory units? Laboratory units, as the name sounds, lab units, okay? They are units of quantities that are measured in the laboratory, okay? So if you take, for instance, micrograms per grams, it's a laboratory unit because the units of the substances are measured in the laboratory. The same applies for ppm and the others. So some of the examples include percentages, milligrams per kilograms, micrograms per grams, and ppm, parts per million. Then what about the field units? Field units, as the name sounds, they are units of quantities that are measured or substances that are measured, okay, on the field or that are measured with respect to the field, okay. So you could have something like yield, okay, which is actually units in agronomy, something like kilogram per hectare. Okay, it's a field unit because it compares mass of a particular quantity to an area of land, okay, and that is field. So you call it field unit. So kilogram per hectare, also pounds per acre, are all field units. Right, you could have a lot of them. Now, in analysis or in dealing with quantities in the lab and the field and the labs, we will meet or we come across some circumstances where we have to make some conversions from one unit to the other. Okay, so it will be very important to learn about how to convert from a particular unit, for instance, percentage to ppm or micrograms per grams or kilograms per hectare and the likes. So in this video, we will delve into that conversion aspect. Now we have a question here to answer, which will be used to guide you or teach you on how to do the conversions. Now our soil contains 0.112% nitrogen. Convert this to I ppm, parts per million, I micrograms per grams, I milligrams per kilograms, IV pounds per acre, and then lastly kilograms per hectare. So now you tackle the very first one, parts per million. Now our value was given as 0.112% nitrogen, and 0.112% nitrogen means that 0.112 percent, even if you say something like 80%, okay, let's say in a class of students we have 60% to be boys, and then um, so definitely the rest or the percentage becomes girls. Okay, so 40% girls. So if you say 60% boys, it mean that in 100 students, we have 60 of them to be boys. Okay, that is the interpretation of percentage. So 2% means that in 100 of the lot, we have two to be something. You understand? So over here, 0.112% nitrogen. You know, nitrogen is a nutrient, okay, a macronutrient that is found within the soil. So that means that we need analysis. If you take 100 grams or 100 parts of soil, we expect that 0.112 of it will be nitrogen. That is the implication of the percentage. Okay, so 0.112 parts of nitrogen is there or present in 100 parts of soil. But then the from the question we have to determine the parts of nitrogen in a million of soil. That is parts per million. You understand? ppm, parts per million. So how much nitrogen is there in a million of soil? So if you have 0.112 parts of nitrogen in 100 parts of soil, how much would it be in a million of soil? So in a million of soil, so S parts would then be in the million. A million is just 10 to the power 6 parts of soil. So you cross multiply, that is the x, you multiply the 100, and then the 0.112 multiply the 10 over 10 to the power 6. So by so doing, you have 100x equals 10 to the power 6 times 0.112. Then we can make s the subject by dividing both sides by 100. That is how we do cross multiplication. Okay, so you end up getting 10 to the power 6 times 0.112 all over 100. And then we get 1120 parts per million nitrogen. As simple as that. So this is how we go about the calculation. Okay, so that is that. Then we move on to the next one. We have to calculate to convert the percentage to micrograms per grams. So this percentage, 0.112% nitrogen, we have to convert it to grams. Micrograms per grams. So micrograms per gram because the units, okay, it's supposed to be, for instance, grams per grams. Okay, how much of nitrogen in grams is present in a gram of soil? Okay, if you say per grams, it means 1 gram of soil. You understand? That is the meaning of the unit. But then we understand that if you are to measure the soil in grams and also the nitrogen in grams, the nitrogen value will be so small that you have a lot of 0 point something, a lot of zeros. A very small value. So by so doing, then we change the value or we change the unit of the nitrogen from the big unit to a much smaller unit. That is the micrograms. Okay, so we have a microgram, which is a smaller unit of grams. Okay, so that we can have a realistic number or value that we can easily work with. Okay, so as we said earlier, 0.112% nitrogen means that we have 0.112 nitrogen parts of nitrogen in 100 parts of soil. Now the parts we are talking about is grams because the basal unit, okay, is grams over here. So it means that we have 0.112 grams of nitrogen in 100 grams of soil, as I've written there. So from the units, I said we want to calculate nitrogen in a gram. That is how much of nitrogen in micrograms is present in 1 gram of soil. So we have to make sure we divide through this equation. That is the 0.112 grams of nitrogen per 100 grams of soil by 100. Okay, so we divide both the numerator and the denominator by 100 so that we can have the down part to be per grams. Okay, we are looking for per grams, not per 100 grams. So we divide both sides by 100. So you have the top side being divided by 100 and the downside also being divided by 100. So you're going to have 0.00112 grams divided by 1 gram of soil. Okay, that is how come we have gotten this. So we divided both sides by 100 to eliminate the 100 at the down parts. Okay, that is that. So we have this. Now you can see that this value, as I was saying earlier, it will be so small that we can't deal with their units. So we have 0.0112 grams of nitrogen in 1 gram of soil. That is a very small number. Then to avoid this, this value, we could change it to micrograms per grams. Okay, we could change the top to micrograms so that we can have a whole number or more realistic number. Okay, instead of the plenty decimals. So you should understand that every 1 gram of any quantity, we have a million micrograms. Okay, so 1 gram of anything has about a million. That is 10 to the power 6 micrograms. Okay, so you can see that microgram is a much more smaller unit of grams. So if 1 gram of soil or nitrogen contains 10 to the power 6, that's a million micrograms, then 0.0112 grams will contain what? So you have to just multiply the 0.0112 grams by 10 to the power 6. So we do that, 0.00112 grams by 10 to the power 6, we get 1120 micrograms as our value. Okay, so the final answer becomes 1120 grams micrograms per grams nitrogen. So it means that in every 1 gram of soil, we have 1120 micrograms of nitrogen. That is the meaning. All right. We move on to the next one. We have to calculate the same thing or to convert to milligrams per kilograms. Milligrams per kilograms. Now, this milligram, these are both units of grams. Okay. With milligrams being a much smaller unit of kilograms, and kilogram is the bigger unit over here. Okay. So with 0.1112% nitrogen, since the basal unit here is kilograms, okay, the basal unit is always the unit, the pair, okay, the denominator. So the basal unit here is kilograms. So it means that we have 0.112 kilograms of nitrogen in every 100 kilograms of soil. Okay, always we want to see how much of nitrogen is in the soil. All right, so that's the meaning of this expression: 0.112 kilograms of nitrogen in 100 kilograms of soil, because the basal unit is kilograms, right? So that is the implication. There's that. Okay, so now we want to, from the units, the milligrams per kilograms is supposed to be per kilogram, not per 100 kilograms. So we again divide both sides by 100. Okay, we divide the top by 100, the down by 100. So we're gonna have 0.00112 kilograms nitrogen per 1 kilogram of soil. All right. Now we've been able to arrive at the something similar to the unit that we are to get. But then the top, you can see that it's very small, 0.0112 kilograms. A lot of decimals, and then divided by a kilogram of soil, as we wanted to get. Now to change the top, the numerator, we try to convert the kilograms to milligrams to have a more realistic number, a whole number. Okay, but you have to understand that kilogram is a bigger unit of milligrams, or milligram is a smaller unit of kilograms. And so 1 kilogram contains about a million milligrams. Okay, so 1 kilogram equals actually 10.6 must come before milligram. Sorry for that. So you have 1 kilogram contains a million milligrams. So you have to just multiply the 0.0112 kilograms by 10 to the power 6 to convert it to milligrams. Okay, so you're gonna have this. So we are also getting 1120 milligrams. So the final answer becomes 1120 milligrams per kilograms nitrogen. Okay. Again, this implies that in every kilogram of soil, we have 1120 milligrams of nitrogen. Now we move to the next question: pounds per acre. Now we have to convert the percentage to pounds per acre. Now this pounds per acre is not just a unit. Okay, you can see that from what's all that we've done, we have parts per million, micrograms per grams, milligrams per kilogram. They are all units of the same quantity. But over here, or substance, over here we have pounds per acre. Pounds is a unit of mass, okay, and acre is a unit of area of land. Okay, unit of area. Let's just say unit of area. Now you can see that these are two different units. So to convert a percentage to this unit, you can't just assume that you can't say that 0.112% nitrogen means that in every, since the basal unit here is acre, you can't say that in every 1 acre of soil we have 0.112 nitrogen acre. Acre of nitrogen. It doesn't make sense, right? So we have something we call a furrow slice. Okay, so if you take a furrow slice from the soil, a furrow slice of the soil, there's the measurement that we usually derive from that. And from assumption, it means that every parts per million, if you double the double of every parts per million always represent the pounds per acre. Okay, the value for the pounds per acre. So if you have 2 ppm, then the pounds per acre becomes 2 times 2 ppm. That becomes 4 pounds per acre. You understand? So to derive pounds per acre, we always multiply the parts per million by 2. That is the main thing I'm trying to talk about right here. So pounds per acre becomes 2 times the parts per million. So over here, the parts per million It was calculated earlier to be 1120. If you remember from the very first question. So over here you have 2 times 1120. Then you have 2240 pounds per acre. As simple as that. Then the very last question, we have to calculate kilograms per hectare. Now, there's a direct relationship between pounds per acre and kilograms per hectare, such that if you have pounds per hectare and you want to get kilograms per hectare, there's a conversion factor you usually use. You convert the pounds per acre to kilograms per hectare by multiplying pounds per acre by 1.12. Alright. So if you multiply the value, whatever that you have, the value that you have in pounds per acre, you multiply it by 1.12, which is the conversion factor. You should always get the value in kilograms per hectare. As simple as that. So earlier, our pounds per acre was calculated to be 2,240 pounds per acre. So to get it in kilograms per hectare, we multiply it by 1.12. So we get 2,508.8 kilograms per hectare. Similarly, if you have the value in kilograms per hectare, and we are to get um, pounds per acre, okay, with this expression, to get pounds per acre from kilograms per hectare, it means kilograms per hectare is known, but we don't know pounds per acre. So since we don't know pounds per acre, we have to make pounds per acre the subject. Okay, so to make pounds per acre the subject here, we have to divide both sides by 1.12 to cancel out. Okay, so we're gonna have pounds per acre equals kilograms per hectare, all that divided by 1.12. It makes sense, right? So that is how we go about that. Thank you so much for watching the video. Subscribe to my channel and like and share the video.